Okay, guys, it took me a while to get to this, and I apologize for that. I was about a week behind. But I wanted to continue our lesson on adding and subtracting polynomials. And oh, we're on the wrong screen. Just a reminder of what the objectives of this lesson were, to decide if an expression is a polynomial. And we kind of covered that. So let me give that a good old check mark here. To classify polynomials by the number of terms, so we covered that last time, and to classify polynomials by degree, and we covered that. And before we get to these two parts, there are a couple of background things we need to know about. So we're going to get to that. What we basically covered, I kind of went over that, is in a little bit more detail. What makes a monomial a monomial? There are specific rules that fit into that definition. And then we talked about degrees of monomials, which is about the level of exponents. And a question about how can a constant be a monomial if it doesn't have any variables. So we did have a discussion on that. And then we did some practice. We practiced looking at some expressions to decide if it's a monomial or not. If it is, we found its degree, and if it wasn't, we discussed why it wasn't a monomial. And then we looked at polynomials and kind of did the same things. Looked at some special names for some special polynomials, classifying polynomials by number of terms and by its degree, and some similar practice that we did before with monomials. So to get started, we really want to look at writing a polynomial in what's called the standard form. And we kind of had a discussion about it, but basically we write a polynomial in standard form, or standard form for a polynomial, is when every term is simplified and its terms are listed in decreasing degree order. So the highest degree monomial in the polynomial would come first, then the next one, then the next one. And we're going to look at a couple of examples. So let's take a look at this one. We kind of wrote out a chart here that was going to kind of help us out. We want to write this expression, 21y minus 3y squared plus 4 plus y cubed, in standard form. So we're going to look at the degree of each term. So we're going to look at the 21y first. First, but it also happens to be a 1 degree monomial because the exponent on that y is 1. The next term is a 2nd degree monomial because of the exponent. The 4 is a 0 term, a 0 degree, and then the y cubed is a 3rd degree. So, and this is the one we had a question about, because we could actually write this 4 as 4 times x to the 0, because x to the 0 is 1, and 4 times 1 is 4. So that's why this is a 0 degree monomial. And now we just want to write these in order from highest degree to lowest degree. So we just also want to make sure that we pay attention to the signs. That's kind of why I wrote this as a negative. So in order of degree, we would have y cubed. There's our 3rd degree. Then our 2nd degree term, negative 3y squared. Then our 1st degree, plus 21y, plus 4. So now we have written this in standard form. Everything is simplified, and they're in order of degree from highest to lowest. So it's not really a bad thing to do, and it's kind of one of the reasons that we will often see, even though we don't like negative terms to be first, but in linear equations we might see something like negative x plus 4, because the negative x has a degree of 1 and the 4 has a degree of 0. I mean, yes, another way to write this would be 4 minus x, which is kind of more pleasing to the eye and pleasing to the mind, but it's not actually in standard form. The other one is in standard form. So, with keeping that in mind, because we always have to keep everything in mind that we've learned before, we are going to talk about how to classify polynomials by the number of terms, or by its degree, or both. And both is actually going to be the most expressive, most descriptive. That's the word. So, just a couple of important names. We've talked about constants. That's a type of an expression. A constant has a degree of 0, and an example is 10. And we've kind of talked about why that is. Then we have what's called a linear expression. And it has a degree 1, and it has 2 terms. So it's a binomial. A linear expression is a binomial. Well, it could be a monomial too, but then we have what's called a quadratic expression. And that's degree 2 because of our exponent here. So we'll have quadratic expressions, and we're going to spend some time with quadratic expressions later on. Then we have something that's called cubic. And cubic, I remember that one because it kind of reminds me of the word cube. So it usually describes a 3-dimensional object, which also reminds me why it is a 3rd-degree polynomial. And it's actually a trinomial. 3rd degree. Well, that is a trinomial, yep. But cubics can be anywhere from 4 terms to 1 term, actually. After cubic is a word that we don't come to very often, except in very advanced classes. It's called a quartic expression, and that's because it's a 4th degree polynomial. It has an x to the 4th term. And as you can see, this is a binomial, but that's okay. It's a quartic binomial. So that kind of tells us that it's a 4th degree with 2 terms. And yes, there's one more called a quintic. And quintic is a 5th degree polynomial. This would be a 5th degree polynomial because we don't have a word for a 1, 2, 3, 4, 5, 6 term expression. So we would just call that a 5th degree polynomial or a quintic polynomial. So those are some of the interesting expressions or words that we use. We'll use them occasionally. They will come up on tests and things like that, so we just want to be aware of those names. So actually, if you look really closely, all these polynomials are written in a kind of specific way, and it looks really complicated, and I so understand that, but that it's going to kind of make you crazy. Here it's basically saying that our highest degree coefficient, or the coefficient that goes with the highest degree monomial, plus the next smallest, and then it keeps going all the way down till we get to our 1st degree, and then to our constant. Now let's take a look at an example here, okay? So we're going to look at this example, 6x to the 5th plus 3x to the 4th minus 2x cubed plus 6x squared plus 3. So in this example, our n is 5. It is the highest degree. It's the degree, basically, of the polynomial. So the coefficient for that is 6. Then for the next one down, well, a to the 5 minus 1 is a, sorry, it should be sub. A sub 4, meaning the coefficient, that's going to be the 3. Next one is a sub 3, because it's 2 away from the biggest. That's going to be negative 2. Yes, I include the negative. That's because we always assume everything is addition. When we see a negative sign, that means we have a negative number. Our next one, 3 away from the biggest, is now the second. So that is going to be 6. Now notice this. A sub 1. Well, A sub 1 should have an x. But our example doesn't have an x. So the coefficient for that one is going to be 0. Because 0 times x equals 0. So it just doesn't get written. So that's where we're often going to make mistakes, is when we're missing an expected term. And then the last one is our constant, which is going to be 3. Okay. Now notice that all these examples are written in simplest form, with the highest degree coming first. And they're all simplified. So it's just kind of to be a little bit aware of this kind of notation that looks really confusing, but if you think about the relationship between n and n minus 1, or n and n minus 2, they'll kind of make a little bit more sense. Let's see. Let's start, because I'm going to run out of time soon on this recording, so we're going to have to go to a second one. Let's classify the polynomial 3c plus 1 by its degree and number of terms. So, I really didn't want this box here. I didn't want you to see it. That's okay. Not the biggest of deals. So, it's a polynomial. Let's see. How many terms does it have? It's got 1, 2. So it's a binomial. And it's a first degree binomial. A first degree binomial is usually linear. So we would call this a linear expression. 3c plus 1 is a linear, let's be more specific, a linear binomial. Let's call it that. We're going to look at a couple more when we come back, and then we're going to actually start working with these polynomials, adding and subtracting them. So I'll be back very, very shortly.